Welcome to Lesson 1, Character Representation. We learned in previous videos that a computing device essentially only understands ones and zeros. That's its language to communicate with. But us as human beings, it's hard for us to communicate like that. So we have to create some kind of abstraction from the ones and zeros to make it more meaningful for us. We saw that by grouping sets of ones and zeros, we were able to represent numbers. Now, numbers is a step up from just plain old ones and zeros, but still, we needed something more because in our natural language, we use letters, we use symbols to communicate with. And that's where Ascii and Unicode standards come in. So let's get to it. So ASCII stands for the American Standard Code for Information Interchange, I believe. You can always Google it and double check me. So what it does is that it's a standard that equated numbers to certain symbols. So I'm going to jump over to 67. So the decimal value 67 is the representation. Actually, I'm sorry, let's do 65. 65 is the representation of the capital A. So for a computer, again, if we were to translate that 65 into binary, it would understand it as the letter A. And then similarly, if you go straight across, 97, the decimal value 97 equates to the value lowercase a. So now we have a way that we can write things. So let's write the words hello or hi, which would require us to translate into binary the number 72 for a capital H and then 105 for the lowercase I. So again, this is our goal for this video. We're going to do hi, where the H has a decimal value of 72 and the I, the lowercase I, has a value of 105. Okay, so we know that the computer communicates using 8 bits. So let's set up our 8 bits. And just make sure we got here. And we'll set the other ones underneath it as well. And let's put our place values in. So this is the 128, 64, 32, 16, 8, 4, 2, 1. Again, in a binary system, again, if this still feels a little uncomfortable to you, what I'm showing you, I will ask you to look at the previous video that talks about number systems. But these are the place values in a binary system. So now the goal is we got to convert that H, which is 72, into binary. So it's easy to see that in both cases, this is going to be the capital H, this is going to be the lowercase I. There is no 128. The numbers are too big. The number's too big to fit into each of these. For the H though, we can put a 1 here, which gives us 64, which leaves 8 left over. Okay, so this one becomes simple. We're not going to take out any 32s. We're not going to take out any 16s. We do need an 8. So a 1 here and a 1 here is 64 and 8 gives us 72. So our job is done when it comes to the H. Now let's handle the 105, which is a little larger. All right, so we could definitely take out a 64. Now, I'm going to think through this a little bit more, make my life a little easier. I know that I can take out a 32 as well because these two together is 96, leaving me 9 left over. Okay, so we have 64, we got a 1 here which is 32, that gives us 96. So now we still got to come up with 9. So that means I can put a 0 here, a 1 here, that gives me 8. So this was what? This was 96. We got 8, that's 104, and that means we just need 1 more. So this is how we now are able to use our natural language to communicate. Now, I'm oversimplifying this. There's a couple of other layers that happen between when you write code and ultimately what happens at the machine level with binary. But this is a good enough overview, of how we are communicating in our language that then gets translated to the computer in its language. So I'm going to flip back over to the presentation. Actually, I should say to my browser. Because as I mentioned, this is the Ascii table, the American Standard Code for Information Exchange. Obviously, this just covers a small a small portion of possible characters. Again, if you were in Europe or in Asia, those languages use different character sets. So for that, there is something called Unicode. And the Unicode covers these characters from all these other languages, whether it's Arabic, Chinese, possibly maybe some Greek letters. Again, I'm not going to go into this, but Unicode characters, you would translate them in a similar fashion. But I will say the character set in Unicode standards is a lot larger than the American standard. And that might be a reason why the American standard came about, because we realized we didn't need all those other characters, because here in America we have a smaller set of characters, being that we use the alphabet. All right, so let's go back to the presentation and let's review what we've done. So, it's important to appreciate the translation that needs to happen between how we speak and ultimately what the computer understands. The computer only understands binary, ones and zeros. So we need a way to represent our characters, our letters, our symbols as numbers that we can then ultimately translate into binary. So hopefully now you have a better appreciation as to the communication that happens between humans and ultimately a computer. And let's see what you can create. Enjoy.